All right, welcome everyone to the Sunday morning session for term one. So, welcome back again. So, today we are going to learn something really important, I should say. I mean, obviously, whatever we're doing has been important, but something which is, mm, in fact, one of the most important parts in the world of algebra, and that is linear equations, right? I'll give you a gist of what linear equations are, how we deal with it, how we solve it, right? And some basics around it. Oh, I can't see the chat now. Where's the chat? Yep, I have it here. All right, so before we kick off, few things and which are most important are rules of this session. Uh, don't distract me, don't distract others. Uh, and the whole point is this is a very, very important topic, and everyone, as I say, has sacrificed their Sunday mornings to come in here. So if you are over an extra intelligent, probably I think it is still an opportunity for you to refresh everything that you know of, right? So just a bit of a warning, anyone who's found spamming in this session probably will be sent back to the waiting rooms and will not be allowed to re-enter for today, right? So please, whenever I'm asking you to put it stuff on the chat, it's only when that I want you to be typing on chat. Otherwise, you should be listening or working out on your notebooks. Uh, so let's get the ball rolling. I will share my screen and I will disable annotation on screen share. So please, when I'm sharing it, I will highly advise don't play around with my screen. All right. I think it's already disabled. Um, and we still have people coming. Give me a sec. There are people still coming. All right. Are you able to see my screen? Is my first question that I want you to answer on the chat. Good. All right. Another important thing, my earbuds at times trips off, and you all of a sudden will stop hearing me, right? So if that happens, you please let me know on the chat that you can't hear me, and I'll quickly fix it up, right? So that has happened in the past. All right, so we are going to learn something called linear equations today. Now, before I kick off, I want you to do a few things for me. And I'll give you some questions and I want you to solve it. Right? If I write 2x plus 5, and I ask you to open the brackets up and give me the expanded form. Answers on the chat now, quick. And there are, how many? There are 35 participants. So yeah, I think this should be sweet, right? Oh, good. 2x plus 10. Good job. Now, if I say 2, in fact, I should say half x plus 6. Can you expand it and let me know the simplified expanded version? All of you, simplified expanded version. Good job. So what I'm going to do, this is called distributive law. The distributive law. What does distributive law tells me? Distribute the stuff outside to every term inside. So what you ended up doing was this 2 is divided by x, and this 2 is divided by 6. But hang on, 6 over 2 makes it a 3. So the answer is 3. All good. Any challenge, anyone so far here? All good? All right. All right. What is not clear, Masin, here? We just have a number outside. You know, when you open the brackets up, you just bang it here. First term, second term, just write them separately and you get your answer. Simple. Now, another one. Open the brackets up, give me the answer. I need you to be quick. I need you to be quick, right? Good job. So this -2 multiplies, no, not 12x minus 6, Arif, no. -2 multiplies by x is -2x, and then this negative multiplies. So -2 times -3 is +6. That is the answer. All right, so far, so good. You are doing fine. Now, just out of curiosity, if I throw something like this, can you simplify this into one single fraction? Take your time and give me the answer. I don't know the answer. I've just made up this question myself here. 11 on 15, a lot of people are saying. Okay, I don't know. Let's see. I will times it by 5 and I'll times it by 5. And I'll times it by 3 and I'll times it by 3. So this becomes 5 on 15 plus 6 on 15 makes it 11 on 15. Good job. This is basic fractions. If you are year 7, 8, even if you're year 6, you should know this, right? Because this, all of that, what I'm going to do after this is required for linear equations. All right. With that in mind, let's understand what is an equation and what is the difference between an equation and an expression. I think this was the very first lesson last year, September, that I digged in. I'll just quickly summarize it again. Anything, for example, if I write x plus 5, this is an expression. And the moment I have placed an equal to sign, it still hasn't become an equation. The equation is like a balance. Equation is like a balance. You've seen that traditional balance, I don't know, they used to be in the great olden times, and people didn't have digital scales. You put stuff here and you put stuff here. So you balance it out so that your needle is in the center. So this side was called the left-hand side, and this side was called the right-hand side, my right. So when I place an equal to sign and I write something on the other side, let's say 6, for example, now this has become an equation. Now, equation has an equal to sign and they have something on the left-hand side which balances something on the right hand side. And this equal to sign tells me that this is a perfect balance. That means the left hand side is equal to the right hand side. So whenever you see something like that, you should know that you are dealing with an equation. Now, linear equation. I have explained this quite many times. What does linear means? Can someone tell me on the chat? Equation, I've understood what equation is. What's this fun of being linear? Can someone write it on the chat? Throw more. Yes. So equation means the the degree is 1. Now, what is degree? I've explained it many times and I'll reiterate it again. The highest power, the highest power of any variable. So if I say x plus 5 equals to 6, how many variables do I have? Only one. What is the power of this variable? The highest power. X is nothing but x is 1. So I can say x is nothing but x raised to the power of 1. So when you have such scenario, this equation is called linear equation. Now, someone just wrote on the chat, a linear equation is that equation which has got one variable. No. So if I have x plus y plus z equals to 1, this is still a linear equation. Why? I have three variables in it, x, y, and z. What is the highest power of x? 1. You see, x is power 1. What is the highest power of y? 1. What is the highest power of z? 1. So it is a linear equation. But in case I write something like this, now it is not a linear equation because the degree is now switched to 2. It has become a quadratic equation. So this is linear equation in one variable. Sorry, this is the linear equation in three variables, x, y, and z. Whereas this bit is linear equation in one variable. So number of variables does not really matter. It is the degree that decides that the equation is a linear or quadratic or cubic or whatever. So we've now understood what is a linear equation. And we've also understood that linear equation is a balance. So in fact, any equation is a balance. So it's just like linear equation. Now let's try to unbalance this. So if I say x plus 5 equals to 6, before I unbalance it, another important thing that you need to understand whenever you're solving any equations are something called inverse or reverse or opposite operations. So positive or not the positive, the addition's reverse operation is subtraction, and this is vice versa. Multiplication reverse operation is division. and vice versa. Always remember that. This is going to be heavily used in whatever we are going to do next. Now, I was talking about unbalancing it. This is a perfectly balanced equation. It's an equal to. Now, if I unbalance it, that means let me throw a number on the left hand side with any operation I want to. I need to do exactly the same on the other side to balance it. In order to maintain the balance, I need to do operations, same operation, probably, same on both sides. So for example, I'll not take this example. Probably I'll say, let's say x equals to 5. Now I change the color of my pen and I say, okay, let me multiply 2 on the left hand side. Now, what happens is that if you have a balance, the needle will be flicked towards the LHS, the left hand side. We want to get it back into the center. So what we need to do is we need to exactly do the same scenario on the other side. Always remember that. In order to maintain the balance, whatever you are doing on the left hand side or right hand side has to be done on the other side. So in this scenario, this becomes 2x is 10. So this equation and the other equation, the original equation, are exactly the same equations. It's just that the top equation has been multiplied by 2 on the left hand side. That's precisely we have to do on the right hand side. So it's just like a balance. So I say balance. If you have a balance again, let's say you've got 2 stones here and 2 stones here. The moment you add 1 stone extra here, you need to add the same stone on the other side so that the balance always remains in the center. That is what linear equation is all about, maintaining the balance. Now, so we've understood what linear equations is, we've understood what linear equations are, and we also understood, how to maintain this fine balance from the left hand side to the right hand side. Now, let's try to start solving a few equations, trying to maintain this balance, but using the inverse operations. Okay, now x plus 5 equals to 6. I know you know this answer, but someone who's new to it, I'm just giving you a perspective. My dear x is sitting on the left hand side. I need to solve for x. I need to solve for x. What it means is that I need to leave x all alone and get rid of any other numbers that it is surrounded with. So right now, this poor x has 5 added to it. So somehow, if I get rid of this 5 on the left hand side, my dear x will be left all alone. And that is what precisely I am after. So Let's try to leave this x all alone, especially getting rid of that 5. How do I get rid of this 5? This 5 is added to x. And my reverse operation here, you see here, addition has a reverse operation or an inverse operation of subtraction. So what I'm going to do now it's very important that I'm going to tell you something. And that's called hygiene, habit. I know that you can take -5, x is all alone, blah, 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 all good. But I'm going to give you something which is called hygiene. What you're going to do is you are going x plus 5 equals to 6. And you're going to subtract 5, right? So what you're going to do is put this in a bracket and subtract 5. Always, when you are doing this stuff, when you're taking the other, when you're doing the reverse operation, always put the brackets on the original equation on the both sides, and then do this operation, the reverse operation. You can also write it like this. But this will actually make it slightly more complicated for you to understand. If you don't understand, forget about it. The first way is the best way to do it. When you're doing addition, subtraction, put a bracket, place it on the right hand side of the bracket. Now, let's open the brackets up and see what happens. X plus 5 take away 5 equals to 6 take away 5. Always place the bracket. And I will let you know why I'm telling you to put the brackets. You will see the magic in some time. I know this might not have been taught in the school to put the brackets, but might have been taught in the school, but could be in certain scenarios. I say every scenario. Now 5 gone. So x plus 0 is 6 take away 5 is 1, which means x is 1. You have finally managed to leave x alone on the left hand side, and you have solved for x. Is this clear, everyone, what I've just done? Simple. This was the basic linear equation, but the point I'm trying to highlight is everyone is placing this bracket. Remember this. Very, very important. I can't simplify better than this. So keep cruising along. All right. I'll do a few examples. Don't worry. Let's change the color of my pen, and my favorite color is blue. All right, let's do one more. X minus 5 equals to 6. 5, I'm not asking you to do it, I'm just doing it. This is a 5 which is subtracting x. I need to get rid of this. So for subtraction, my reverse operation is addition. So I will say x take away 5, brackets, plus 5, brackets, plus 5. Open the brackets up. 6 plus 5 is 11. Gone. X is 11. Easy peasy. So far, so good. We're dealing with very, very simple examples. All right. Aryahi, you're fine? Yes? Oh, good. Cool. Now, let's do 2x equals to 11. Now I have 2x simply means 2 times x. So it's a multiplication. So for multiplication, the operation is division. I told you, the reverse. Let's try to do it. I'll say 2x bracket divide by 2 equals to 11 divide by 2. I can place it here as well if you want, whatever is convenient. I could have also written it like this, but I still want you to use brackets, right? That's why I sort of have put the brackets first and took this 2 out. And I have to put 1 on top, right? Because I'm dividing by 2 means it's a half. So when I open the brackets up, this is what it becomes. Now 2 and 2 cancels, 2 times 1s and 2 times 1s. Please note that whenever you are canceling something like this, it's not a 0. 2 divided by 2 is 1. A lot of students do it as 0, which is not the case. Equals to 11 over 2. I can't divide 11 by 2 if I want to keep it as fraction. Obviously, I can if I want decimal answers, but I'm not interested. So this is 1. So eventually, I have x equals to 11 over 2. So now I have left x all alone on the left-hand side. I call this is my named strategy. When I'm using this word that leave x all alone on the left-hand side or on the right-hand side, I call it as leave me alone strategy. So dear x is saying leave me alone. The moment you leave x alone, x becomes the subject. That is what we are after. Now, let's try division. X over 2 equals to 11. Can you quickly tell me what will be x? 10 seconds answer now. Not x plus 12, not x plus 22. X equals to 22. There's no rush to the finish line. All good. Wonderful. Simple. What have we done? Change the color of the pen. I multiplied it by 2 on both the sides. Why? Because 2 is getting divided with x. And in order to get rid of this division of 2, I just do the reverse operation. Open the brackets up. You have 2 times x over 2, 11 times 2. 2 is gone, 2 times 1. So x equals to 22. All right. Now, let's go a step further down. And let's try to complicate a few things. Okay. 2x take away 6, and I don't want you to attempt it right now. I have another question for you before you actually start solving it. So don't solve this question. Now, I want you to answer a few things on the chat. In order to leave x all alone, my dear x all alone, on the left-hand side, what are these two numbers that I need to get rid of? so that x is left all alone. Give me two numbers that are surrounding x, that are actually troubling x, basically. 6 and 2, obviously. I should say probably a positive 2 and a negative 6. They are like, the numbers should be called out with their signs, positive or negative. Okay? 6 and 2 is fine, all of you, but not 10. 10 is quietly sitting on the right hand side. It's not barging into the privacy of x. X, in the house of x, 2 and 6 are sitting, positive 2 and negative 6. Poor 10 is on the other side, right? He's in the neighbor's building, not in x's building. All right. Positive 2 and negative 6. Cool. Can you now tell me on chat? Can you now tell me on chat what first number out of the two? I'm not after answers. Shadow, Aradhana, I know you know stuff, Karan. If I'm speaking really slow today. If my conversation is not making sense, I can't go slower than that. Let's hear it out and pop stuff into the chat that I need. Okay? No answers. As I said at the start, nothing in the chat will go till the time I tell you to. All right? Now, hear me out loud and clear. A lot of people here don't know this. So don't spam chat. Just follow my instructions. Okay, coming back. I have these two numbers, which are sitting with x, I need to get rid of. Which number out of positive 2 and negative 6 should I get rid of first? I need all of you to answer now. I'm looking at the chat. I'm looking at the chat. Good. You said negative 6. Okay, I take your point. Another question to you now on the chat. I know you all agree, I think 35 or 36, how many of you are today here? You all agree, 39, pretty much the same number. That negative 6 is what I should get rid of. Can I? Another question. I need an answer in yes or no. Rather than touching negative 6, can I get rid of this positive 2 first by any chance? Or I cannot? Okay, I can. So why at the first place did you say negative 6? You could have answered me, you can get rid of either. When you knew all of these answers, that means when you told me it's nothing called faster, how quick your brain functions is what it is, right? There's nothing called simpler or hard, right? How your brain functions is what it is. That's about it. Let's try to get rid of 6 first and then 2. So we'll get rid of negative 6 and then positive 2. Try to solve it. And then let's try to get rid of 2 and negative 6. Let's try to do it. All right, let me do the first one. Let me get rid of the negative 6 first. So what I'm going to do is 2x take away 6 is 10. I need to get rid of this negative 6. I'll place the bracket. And probably I will say a positive 6 and a positive 6. I open the brackets up because why I did positive? Because the reverse operation is addition. 6 gone, 2x equals 16, and then I say, okay, let me just divide it by 2. So when I open the brackets up, 2 gone, x is all good. Is this making sense? Right, everyone? All right, now let's try with 2. Okay, before I try with 2, let me change the scenario for you. Let me try a different question. Rather than a 2x take away 6, I change the question and I ask you the same question. And we had what on top was 10. Okay. Can I get rid of this 5 first? Answer on the chat. Okay. Now I can't see you working out, but so I have to work it out. So I'm just giving you options. You can get rid of any numbers. So in case you've been taught in the school or wherever that you want to get rid of the addition subtraction first, I mean, you can do anything. Let's get rid of this 5. Get rid of the positive 5 and then negative 6. Let's try doing it. This is where the bracket plays a big role. I have 5x take away 6 equals to 10. I change the color and I say, okay, let me get rid of the positive 5 first. That means 5 is multiplying x. I need to divide by 5 on both the sides. Let's open the brackets up. 5x times 1 on 5, take away 1 on 5 times 6 equals to 10 over 5. Is this step clear what I've just done? Now 5 gone, which means 1. So this becomes x take away 6 on 5 equals to 5 times 1 and 5 times 2, which means 2. X take away 6 on 5 plus equals to 2. Now I can rather than getting rid of this 6, now that negative 6 is not there anymore. You've got another person sitting with x, which is negative 6 on 5 rather. So I have to add 6 on 5 to get rid of this guy. So I have x take away 6 on 5 in the brackets plus 6 on 5 equals to, I had a 2 here, 2 within brackets plus 6 on 5. It wasn't 2 take away 6, it's 2 plus 6. So now I open the brackets up. And I chop this off. So eventually, my dear x is happily sitting all alone on the left, whereas it's just the matter of solving this fraction. Can you quickly solve this fraction? 2 plus 6 on 5. What is the answer? $16 on 5. Or as you said, 3, 1 on 5. So now I have the x being left all alone using by taking the number that was most closest to it, the coefficient of x, getting rid of that first. So the point I'm trying to make is that there is no definite number that you need to pick up first. Pick up any number that you want to get rid of x, but ensure that you are using brackets. That's about it. Now, with that in mind, and I've spoken for 44 minutes, let's get the ball rolling. Now, I cannot see your working out, but whatever way you feel that you're comfortable with, leaving X all alone, I leave it up to you, right? And I'll give you another question starting now. Let's do some questions. Anyone who hasn't got this, everyone is clear what I've just taught you. Linear equations in its simplicity is what I've just talked about. There's nothing more to it. If you just pop your brackets every time, you'll never go wrong. Okay, let's try doing this. Give me X, please. Slok X is not 24. X is 18. Let's quickly do it. What number did you choose? You all chose to get rid of first. A division of 3, positive 3, or a positive 1? Because you found the easiest way, right? I think you said 3, getting rid of 1 is easy. I will get rid of 3 first. Let's try and validate your answer. I will say, okay, this 3 is basically dividing. I will say I will multiply the whole expression by 3. I'm just giving you another way of looking at it. That's about it, right? Just giving you another perspective. Now, when I open the brackets up, this gets multiplied on both the sides. So 3 times x over 3 plus 3 times 1 equals to 3 times 7 is 21. 3 gone. So x plus 3 equals to 21. And now I'll say, okay, let me get rid of this positive 3 by taking the stuff in the bracket and taking it out. So x plus 3 take away 3 equals to 21, take away 3, gone, gone. X is 18. Someone said getting rid of 1 would be faster. I don't care. I was pretty fast here as well. All right, cool. Now, we knew that x is 18 here. But how do I know the last piece of the Lego? How do I know that the answer that I have calculated is right or wrong? So there is a way, or probably you might know it as well. It's called checking your answer. So what it essentially means is that you go back to the original equation, x plus 3 plus 1 over 7. So we had the original equation was this, y equals to what? That was 7. Okay. And I have got x as 18. Change the color of my pen so that this is visible, that I'm checking the answer. So what you're going to do now is substitute sub x equals to 18 in this. expression. In this expression on the left, which means this equation, should I? Let me just plug in x equals to 18. So I will say 18 take away 3 plus 1 equals to 7. 3 divided by 18, sorry, 18 divided by 3 is 6. So I'll say 6 plus 1 equals to 7. And finally, 7 equals to 7. If you get this, your answer is right. I think someone said 24, and I know that's not right, but let's quickly try 24 and see if you have calculated anything in the exam. You want to validate it. Let's sub 24 here. So now I'm subbing x equals to 24. I think someone solved it for 24. That's fine, Shlok. So I know you got your mistake now, but I'm just trying to make it sort of, clear to everyone. So if I say 24 over 3 plus 1 equals to 7, this is 8. 8 plus 1 equals to 7. 9 is not equals to 7. So the moment you get that sort of a scenario, it's not right. Which means the answer that you found is incorrect. All right, cool. Let's try doing one more. 3 m minus 4 plus 8 equals to 5. Go for it, please. Good. M is 3. Anyone who did not understand this, just pop in the chat that I don't understand. Anyway, I'll do it. Now, if I, all right, I'll do that, Karan. Now tell me, all of you, which number did you got rid of the very first on the left-hand side? 8, 8, 8, 8. Okay, all right, okay. Hmm, 8. Can I get rid of 3? Can I get rid of 3? I can, right? No one's stopping me from getting rid of 3. It'll make it slightly more complicated. Let me just get rid of the 8 first, and then we'll go from there. Let's get rid of the 8 first. So I will say 3 m minus 4 plus 8 equals to 5. And I say probably get rid of the 8. So when you open the brackets up, the outer bracket, this is negative 3. 8, 8 gone. So what you're left is 3 m minus 4 equals to negative 3. Now at this point, I can go in two different directions. So all techniques are right. It is just that what you are comfy with. I can get rid of this 3, or I can choose to open the bracket. Let me open the bracket first. It's slightly longer, but let's try to do it. Open the brackets up, it becomes 3m take away 12 equals to negative 3. And then I can then have to choose what I get rid of here again. I'll say, okay, let me get rid of this 12, negative 12. So I'll say 3m, take away 12. I'll add 12 on both the sides. And eventually I open the brackets up. This is positive 9. 12, 12 gone. 3m equals to 9. And now I can get rid of 3 by dividing it by 3. Always ensure the brackets. And 3, 3 gone. 9 on 3. M is 3. Because 3 times 3 is 9. Now, let's try to go in another direction from here, and I'll change the color, is this direction. Now, I was here. Rather than opening the brackets up, I open the brackets up here. I get rid of this 3 straight away. So what I do is I divide it by 3. So what I'm going to do is I'm going to say 1 on 3. And within the bracket, I have to place a bracket. 3, and I'll stuff right everything as is. Another bracket inside, a double bracket. My last warning to people who are not listening to me. Now you are at a point that you're starting to annoy me, all right? And you're breaking my concentration. The moment I see one more message on the chat, you're gone. It's a warning. You're gone. Okay? All right. So coming back, I open this becomes slightly more, you've got multiple brackets. Open the outside bracket first. So when you open the outside bracket, this 3, 3 is gone. And in here, this 3, 3 is gone as well. So what you're left with is m take away 4 equals to negative 1. And now I need to get rid of this 4 by adding 4 on both the sides. And eventually, when I open the brackets up, 4 plus m take away 4 minus 1 plus 4, 4, 4 gone, and m is 3. So you land in the same spot at the end of the day. Is this clear? Everyone? Good. One question, and which one is a faster? Honestly speaking, if I were to take that route, I will prefer maybe this side of things. Probably. Yeah, my brain is more tuned to do this. Okay. I write the same question again, and I ask you a question. Write the same equation again. Did we have anything else with it? No, plus 8, sorry. That This was the question that I asked you. I need the answers in yes and no for the last 2 minutes. Can I get rid of 8 first? All of you be attentive of what I'm asking and of what I'm going to tell you now. Can I get rid of the 3? We've seen that. At the first place is my question. And now my golden question, can I get rid of -4 first? Tell me why I cannot get rid of -4 at the first place. Absolutely right. So the number which is being protected by the bracket, you cannot get rid of that number at the first place. It's only the open numbers. For example, 3 is sitting open, 8 is sitting open, and it's only then that you can get rid of this. You can only get rid of this, not the stuff sitting in the bracket. If I have to, my last question, 10 a.m., if I really have to get rid of -4, what should I do on the left and what should I do on the right to get rid of that? If I have decided that I need to get rid of this, what should I do on the left and hence on the right to get rid of it? You told me no, it's a bracket, blah, 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 whatever. I say I still need to get rid of this guy. Answer now. You can't add 4. Sorry, not incorrect. All of you, just one guy. Yeah, I think Kartiki has said it right, and this was one more. If I just scroll up, Kartiki and probably Neri. Yes, this I need to add 12 on both the sides in order to get rid of this 4. And I will not explain why. And I want you to think about it. Okay, I'll not leave it as a mystery. 3 times 4 makes it a 12. Exactly. You expand, you open the brackets up. This -4 is not -4. It's actually -12 sitting in disguise, camouflaged in numbers. So actually, you need to get rid of 12, not 4. With that, I rest my session to peace. Thank you very much for your time today. And I will see you all back next Sunday with more fun. Enjoy the rest of your Sunday. Have a good one.